This video presents a tool called MecaTroniX developed by MecaTroniX Engineering. It is a productivity tool for Matlab and Simulink use. It helps engineers to devote their time to designing. Simulink gives a great capability to design complex code thanks to blocks and lines interface without being an expert in coding. And then, as your model is getting bigger and bigger, you may more and more often encounter some difficulties to add and modify code, share with other designers, debug, etc. As a result, you may have already noticed that time for functioning, this is to say, laying out the blocks, connecting them, correct wrong connection, may be higher than time for designing, control laws, models, etc. But still, these actions are necessary, even though they do not really bring values to your process. MecaTronics tool principle is to minimize this functioning time so that engineers can devote time to designing. So how we achieve that? It is achieved by automation of low added values tasks by organizing the Simulink code on the basis of modules, assemblies, and architecture, so that modules and architecture are actually the work area of a designer. Other tasks, mainly files management, layout, and connecting, are undertaken by MTX. MTX is, by the way, the short name of MecaTronics. So this is pure organization, and as you get organized, you can save time. These are the foundation for the three values of the tool, which are modularity, efficiency, and community. We will briefly demo it in a minute, and functionalities of the tool are reachable thanks to a classical Matlab graphical user interface. Organizing your Simulink code upon these modules, assemblies, and architecture bring three categories of functionalities. Basic functionalities, which are management like versioning, community functionalities, it helps people to work together, to exchange, and Simulink functionalities. Most valuable functionalities is the auto assembly, which, starting from a set of modules, automatically lay out modules upon an architecture and automatically connect them together according to simple naming rules. And architecture is changeable at will depending on the system you want to control or to modelize. The tool includes its own tutorial, so let's have a quick example. So we go to the Matlab installation, and we can launch the graphical user interface with this instruction. And so basically at the top you can choose the view and you can recognize modules, assemblies, and architecture, and at the bottom you have all the functionalities that are enabled or not depending on the current selection. As we said, tool integrates its tutorial reachable thanks to this tutor button, and if you click on it you will see that there are main step and sub-step. Main steps describe module, assembly, auto-assembly functionality. It also describes the architecture design, community functionalities. And in this video we'll see an example of what an auto-assembly looks like. So we choose this step and we press valid without setting the context first. And as we can see, it opens a page in the Matlab web browser thanks to the publish Matlab function, so that you can read it as a classical user's manual. And now we do the same, but we also check the checkbox set context, and now you have the opportunity to practice according to the page of the web browser. So now you can, as you can see, the context is setting, and some Matlab links are now active because of the context. So now in this context, as we can see, and if we go in the modules view, there are some modules already installed by the context. And for example, if we take a look at the first one, which is called ANA, it stands for analog, and B for B sensor, version v0.0. And if we open it, this is actually analog decoding, very classical measurements, which with an offset and a gain. But this is not the point here. So of course there is some other modules, and if we go to the assemblies view, there is already an assembly which is called ABL Training VU 1.4, and if you want to inspect it in details, you have access to this ABL view, and now you will see on the table on the left that all the modules we've seen before are actually in this assembly, plus an architecture which is called Archie Training VU12 is attached to this assembly, meaning that you want all these modules to be assembled upon this architecture. So let's have a look to this architecture by Open Archie, and of course an architect has designed this architecture, and this architect apparently decided to design a measurement floor with a room for CAN decoding and for analog decoding. Okay, it is the same for the CAN decoding. Okay, and decided to have a monitoring room, I guess, to monitor measurements and the overall system behavior. And in the control floor, he had a very classical structure with targets computing and feedback computing. And of course, as you may know, modules beginning with the prefix targets aim to go to this room. Modules beginning with the prefix FB go to this room. And now if we press auto, it will auto assemble the assembly. The auto assembly has been done now, and first we have a summary of the variables that have been found in the calibration script for each module. For example, for this one, there were these variables. For CAN-BIS video D0, there were these variables, etc. And there is also, of course, a Simulink model, and input and output have been automatically created according of what is inside. And inside, if we go inside, of course, you will first recognize the architecture. And if we go to the analog room, of course, we have the ANA-BIS V0.0 module, which has been laid here and connected. And if we go to the monitoring room, of course, we would like to see the 6 monitoring modules in the assembly, and of course this is the case. And we can see here different graphical signs. For example, if a signal is not used at all in the assembly, then it is not transmitted. It is connected to terminator. And if a signal is redundant, sometimes it happens, then it is connected to a red terminator. In that case, sometimes it may lead to missing signal, which is the case because redundant signal is not available anymore. So it is connected to a zero constant, but a signal can be missing in itself. For example, this signal is expected from the analog room, but is not available, is not calculated in this room, so it is connected to a zero constant. As you can see, some go to and from are really near the module. This is because these signals are only used inside the room and are not used outside of the room, so you can quickly check this. And finally, if we go to the targets room, the feedback room, sorry, there are the 2 modules, and there are some rate transition. They are inserted automatically according to an option because it enables different modules at different sample rates to talk to each other. And there is also, you can notice here, unit delay has been inserted. This is because MTX detected an invalid function call, which due to this loop, and according to this Simulink documentation, the best way to treat that case is to insert a unit delay, which is automatically detected and treated by MTX if it is required by an option. So what is important to get at this point is that you can focus on the design of the module and without being concerned with laying out and connecting tasks which are undertaken by MTX. Of course, here we had this architecture at the very beginning of a project. You may not really know how to organize a control, so of course there are different architectures available, and this is very useful to start with an empty one, and because it does exist. For example, if we open an empty architecture, there's only one input and one output, and little by little you may have this kind of architecture depending really of your system. So this is what could be briefly shown on the tool, and there are several other functionalities explained in the tutorial and integrated in the tool. But recently we added a website which is called MecaTroniX with an e.com, and if we take a look at it, this is then possible to take benefit of this page. So first we have an home page, very classic. There is a presentation that you can download for further presentation in your organization, and there is a tutor page, and this is what I was about to say. This tutor page is exactly the same content that the web page that we've seen inside the tool, and hopefully the target is to have a video per step to understand what it's all about. And then we have a contact page, classical page for any remarks or comments that we will be glad to receive. And finally, sources page. If you want to test the tool, you are more than welcome, and you can do that with this page and follow the instructions to download and test the tool. And well, finally, let's say that at this stage of development, the goal is to get feedback about the relevance of this tool, which can be used as a prototype and not as a finished product yet. We are aware that the tool could be faster. It needs improvement. It is not guaranteed bug-free, but the concept can be tested. Moreover, other new functionalities are ongoing. Last important point, note that MecaTroniX is basically and simply a Simulink code organization. As a result, users may still use modules, assemblies, and architecture without the tool. Well, thanks a lot for watching, and we look forward to hearing from you.